Well, good afternoon, everybody. I'm glad to be here. I'm glad to see some of you have stuck around for the end of the conference. I'm really pleased to be here today and to introduce you to Qorvo. For me personally, it's the first opportunity for me to be here in the Middle East to showcase Qorvo's portfolio. So really looking forward to guiding you through what Qorvo is offering, particularly in the aerospace and defense market today. So just starting with a brief overview on Qorvo, who Qorvo is, what kind of products that we're developing, give you a little bit of an update what we're seeing from a global level on aerospace and defense, market trends, what's driving some of the investment that Qorvo's doing into the aerospace and defense market, give you a little bit of an overview on Qorvo's roadmap, portfolio, and really what that is leading to from a product integration perspective. And then just give you a brief overview on what support structure that we have here at Qorvo. So just a brief overview of Qorvo, who we are. So it's approximately 6,100 people. We have revenues of 3.8 billion, and we generate we sell around about 8 billion products per year. When we look at that 3.8 billion, that's split across multiple markets. So Qorvo, as a company, we have a large mobile handset market that represents around about 70% of our revenue. 30% is coming from the non-mobile market. Of that 30%, around about 400 million is coming from aerospace and defense, and that number is growing annually at a double-digit growth rate. Qorvo it has its own fabs, so we are a vertically integrated company. We have a GaAs, GaN, BAW, SAW filter fabrication facilities in the US. So these are the different process nodes that we're offering for different types of applications. So if we look at gallium arsenide, we're offering a VPIN process. This is dedicated for limiter type applications. From a GaAs perspective, we have the 0.25, 0.15, which can be used as both power amplifiers and as LNAs. And then the newest process is a 90 nanometer GaAs process that's focused on high frequency LNA products. From a gallium nitride, this is where Qorvo's commercialized a new process technology. So Qorvo is spending hundreds of millions of dollars in investing and developing new processes. So gallium nitride is predominantly used for a power amplifier applications. So when we're looking at different frequency bands, we can be talking from DC to 42 gigahertz today. So looking at the QGaN 25 to the QGaN 15, these are released products. The 90 nanometer process will allow us to go higher in frequency. So that will allow us to get up to W-band frequency. So all the way up to 100 gigahertz of capability. So the other thing you may notice is all of these wafers now are moving to 6-inch. The benefit of 6-inch is really the volume that we can drive from moving from 4-inch to 6-inch. You can get 4 times the quantity of die per wafer. And as we see that the growth in the aerospace and defense market is accelerating, capacity becomes increasingly important. So having your own fabs being vertically integrated, having large diameter wafers really allows for you to scale with the markets as they adapt and grow. So in addition to these 3 locations, we also have locations dotted around the world, design locations in the US, in Asia, and also in Europe. Not yet in the Middle East, so we'll see how that pans out. So looking at typical modern warfare environment, one of the key factors is communication, being connected. So we're developing solutions for a multitude of different end markets that leverage off the technology that we have in-house. So from the power amplifiers to the LNAs, to integrating those into front-end modules, supplying the PMICs and the power control solutions that go into those modules allows us to target and focus on those, on how the modern warfare, modern field looks today. Other areas that we offer are foundry services, so a customer can come to Qorvo and design their own products into Qorvo. We can also package those products into QFNs or other styles of packages, and we can also do advanced package assembly. This is where we can take either Qorvo's products, our customers' designs, and integrate those into a 2D, 3D package to allow for high levels of integration. So, key for the aerospace and defense market is high levels of integration today. We're seeing the trend to move from open-face radar to phased array radar. This means a higher number of elements in a small space. That means you need a high level of integration. So Qorvo is offering the solutions to integrate a higher number of elements into a small form factor. So just from a frequency coverage, from an application standpoint, we're covering from DC through to 45 gigahertz today, so DC to the Ka band. Going forward with the new releases with GaN 09, it'll allow us to go all the way to 100 gigahertz. Yes, okay, so, sure. Looking at the GaN market in particular, we have, this shows why we're investing in gallium nitride. So from a market standpoint, we see the growth going from a couple of $100 million in 2018 all the way to close to $1 billion of RF GaN spend in 2028. And Qorvo, with the in-house process technologies, is in the right place to benefit from that trend. Why the trend? The trend is coming because of the need for wider frequencies. Gallium nitride, being a wide bandgap material, allows for very wide bandwidths, large frequency coverages. So for EW and SATCOM, you have a very wide frequency need. And also, you need some versatility, so multifunction radars. So having the potential to cover S-band and X-band, all with a single amplifier. So yeah, this is the main reason that the Qorvo is investing into gallium nitride. Really is a high growth rate driven by aerospace and defense. So some other market trends, we look at high versatility and asset consolidation. This is really about knowing where your equipment is on the battlefield. So you've seen a lot more devices connected, either via satellite or via other data links, and those data links are growing in bandwidth and need. You need higher powers. So gallium nitride has higher power density than LDMOS and GaAs. So in a smaller square millimeter form factor, you can get more power density. This allows for, again, those higher powers. And also, we see that the traditional TWTs, from a reliability standpoint, they have suffered. So solid state is a much more reliable technology than using TWTs. And then high levels of integration. As I said, moving to phased array radar means that you need to have a lot more RF content directly behind the antenna, and integrating is the only way to allow to do that. So Qorvo is one of the few suppliers in the market that can integrate multiple process technology, multiple functions into a very small form factor. So this really plays well to Qorvo's strengths. So looking at the type of products that Qorvo is offering, and I've really given this a high-level overview. We're developing the small signal components that can take your signal from IF to RF. And we have a number of different product families from LNAs, which is one of the most common product areas that Qorvo is known for. But we do also have phase shifters, limiters, mixer products as well, and it's a broad catalog. So this catalog will cover from DC to 40 gigahertz. Other areas are the power amplifiers. So we have different flavors of power amplifiers depending on the need. So we can go from discrete products through to full SSPA. So this is the SSPA is a fully waveguide output product where we're combining multiple mimics. So it can be combining 16 mimics with very low loss to deliver very high output powers at high frequency. So again, it's optimizing or providing a subsystem for our customers to easily integrate into their final product. And we also do front-end modules with power amplifiers in. So the power amplifiers, they can be from a couple of watts to 12 watts of power. We can add a LNA, switch, limiter, all in a very small form factor. So in the case of most of our front-end modules, they come in a 7 by 5 millimeter front-end module. The PA themselves would be in a 5 by 5. So you're getting a significant amount more functionality in approximately the same form factor. And then we have filters as well. So one of the key areas that the Qorvo brings is also filtering capability with bulk acoustic wave and surface acoustic wave technology. Again, this is all in-house to Qorvo. Today, we can go from IFF frequencies to 6 gigahertz, but we are developing solutions that will take that frequency, extend that frequency all the way to X-band, potentially KU band in the future. Other product areas new to Qorvo is we acquired a Wave around about 1 year ago, and this gives us access to beamforming technology. So also key to developing new radar solutions is having the ability to beam steer the array. So the Wave solutions allow us to do that at different frequency bands. So we have different markets targeted with those different products. So we have solutions for 5G. We have solutions for SATCOM. In the SATCOM area, we're seeing a lot of new development going on right now. Currently, we're on the 2nd generation product. We are moving to the 4th generation product very soon. This will allow us to improve the performance even further, so get better noise figure and get a higher linearity with the same DC power consumption. And then we're doing beamformers for aerospace and defense. This primarily today is we have solutions for X-band. We are doing a 2nd generation X-band beamformer chip that again will improve the performance both from a linearity, noise figure, and also current consumption standpoint. In this area, in aerospace defense, we've also done a lot of custom design work, and that is also part of Qorvo's strategy is to both do commercial off the shelf, but also to do custom design solutions as well. So this is a typical architecture for a radio that Qorvo works with, and as blue building block, we have everything after the DACs, ADCs, everything in the front end. Qorvo is in the position to supply a solution for. So we have all of the individual building blocks, and then we look at, well, what can we target for individual applications? And these are some of the key applications that we see in the marketplace. So this is an example of an X-band phased array radar where we've got some world-class performing components. For example, the LNA that's used here, the CMD319C3, it has a sub 1 dB noise figure at X-band frequency. So best performance, good linearity, and this is the type of solution that you need when you've got thousands of these elements in each radar system. So, Qorvo is leading the development of new products, making sure that we're developing products that are suitable for the market that's intended, but we're not just doing me-too products, we're developing best-in-class, world-class products across the entire frequency range. So these are just an example lineups. We have similar lineups that we could do for S-band radar, for C-band radar, for KU-band radar as well. So we have all of those individual building blocks for all those different frequencies. So Qorvo is one of the few companies that has such a widespread of both components, but also the frequency range that we're covering. And for EW, we have a similar complement. This is a typical application where you may need to cover from DC to 40 gigahertz. So we have the small signal components that cover that frequency range. We also have the power amplifiers that cover that frequency range. So these are some of the key parts that we see in the market that are dominating in the EW market space. But there are definitely a lot more from Qorvo that we offer in the portfolio. And then looking at SATCOM, we've seen a massive uptick in SATCOM in terms of the need here. And primarily this is driven from, again, that knowing where your assets are on the battlefield and having the availability from a LEO constellation to be able to communicate via satellite. So we're seeing that the beamformers and taking the signal from RF down to baseband, we're seeing a lot of traction there, and we're expecting that to continue to grow exponentially as that market develops and as the network develops. And really that's what it's about, is having the network in place to be able to justify the investment into the SATCOM. Now with Starlink and other constellations, it's given us that ability to, it's given customers the ability to communicate with the satellite at very low cost. So also at Qorvo, we have the standard products, but we have the ability to add additional value. So we can upscreen to space qualification, so we can screen pretty much all of the portfolio from the standard off-the-shelf components to space level qualification. So this can be varied based on the need. So some LEO constellations need very little in the way of screening, whereas if you go for GEO constellations, they need full Class K screening. So we can do that with the die and the plastic packaged and the ceramic packaged parts. We're working on doing that with hermetic packages as well. The next step of value add is really what I've talked about already, is creating modules. So we take a customer need, we understand what that need is. They need to reduce the size of the implementation, or they need to simplify their own design. Then we can integrate multiple building blocks into a module. So in the case of the middle picture here, the QPM 2100, we've taken a 2 limiter die and combined those, and it significantly reduces the overall form factor of the discrete implementation. The advanced packaging, this is really the next level of where we can head as an organization. This is where we're leading the market in terms of capability. So we can take a 2D or 2.5D, 3D package. We can have the RF chips on the bottom side of the package. This allows us to get the heat out of one direction and the RF out of the other direction. So this is where we get into the topside cooling of our devices. So it's in development, it's on the roadmap, but we will be able to have a topside cooled SIP package that would incorporate beamformer, it would incorporate the PMIX to control the gallium nitride, it would have the gallium nitride PAs, the LNAs, switches, all into a very small SIP package. So this is where Qorvo is adding real value for the market. These are a couple of examples of front-end modules that are released today, where we at Expand is where we're seeing the most traction right now. But we do have one front-end module that covers the EW frequency band, which is 2 to 18 gigahertz. So the QPF0219 is 2 to 18 gigahertz, 10 watts across that entire band. One of the advantages also of doing front-end modules is export licenses. As you integrate into a module, a 3A001 part, which is a control part, which would require a license. Integrating that into a module now means that it would be license-free. So that's another positive thing for this market, where there may be some concerns on export licenses. There are ways to work with the export regulation rules to negate the need for export licenses by integration. So you get the benefit of integration, but you also get the benefit that we can export these products anywhere. So these are just half a dozen examples of other Expand front-end modules that we've done, but the intent is this is a multi-chip module where we're integrating a GaN die a switch die, a LNA die, and also a V-pin limiter die. So we can integrate multiple mixed technologies into a very small form factor to deliver a better solution that meets the market needs. So just quickly talking about some of the filtering solutions. So we have temperature compensated SAW and BAW filters. Here what we have is a distinct difference between which technology we use based on frequency. TC SAW is really dedicated for 1.5 gigahertz and below. BAW filter really pays dividends when you go above 1.5 gigahertz. So we have both process technologies, and particularly with the BAW filter, we're looking to expand that frequency range all the way up to 10 gigahertz or higher in the coming 12 to 24 months. So what can we do with filters? Filters have been around for a long time, but with BAW filters, we can really shrink the overall implementation size again, and we can also integrate with other product functions. So in the case of what I'm going to show you next is where we've integrated multiple filters with switches, so we can create a switch filter bank. And this is becoming much more important as radars become more digital. So they're going from RF directly to the baseband. So you need more, or the need for filters becomes more and more. So that's where we're also working on right now and developing those multi-chip modules for filtering solutions. So this is just a quick overview of the roadmap, and you can see that for the low frequency, we're utilizing SAW filter technology. For the high frequency, these are all BAW filter based solutions. And this is the switch filter bank, where we've got 8 different filters, each between 25, 50 megahertz of bandwidth, and then a bypass and a switch that can switch between any of those different filter banks, giving very good performance, and it significantly reduces the overall form factor and implementation that you would see with a cavity filter or other filtering solutions that are in the market today. So where does this all bring us? So this, I've talked a lot about the different building blocks, a lot about the integration. This is the longer term vision, and this is why we're developing all of the different technology that I've spoken about today, is where can we get with the high levels of integration. So today we've got the single chip components, front end modules. We've demonstrated what that might look like in a tile approach for a phased array radar. The PMICs that are needed to control both the gate and the drain voltages for the gallium nitride, we're developing those chipsets that can drive 4 different devices simultaneously. We then can integrate that into a flat panel demo to show that capability. So this would be about 7 centimeters by 7 centimeters large. So it has both the beamformer IC, the front-end modules, 10 watts, the driver amplifiers, and also the biasing chips into that 7 by 7 millimeter. So it's driving 4 channels in a small space. But the ultimate goal is to integrate that into a single SIP solution. So you go from what would be approximately 16 by 16 centimeter size to implement, down to 7, down to about 30 millimeters by 30 millimeters. So 3 by 3 centimeter type size package. We can fit a 4 by 4 element array into once all of this technology has been developed. So that's the kind of the long-term strategy that we have from a roadmap perspective. And the last slide is really just to highlight the contacts that we have. So, in Qorvo, we do have a large application support team based in the UK that can support the region locally. But we also have some field applications and product applications team back in the US that can answer some more detailed questions. And we also have the inside sales support locally here in Europe as well. So that was it. Thank you for your time.